Section 5.4, more trig graphs. Let's start with cosecant. You remember, I hope, that cosecant is 1 over sine, correct? Yes. All right, so what I'm going to do is I'm actually going to draw a sine wave. So remind me again about a sine wave. What does a sine wave look like? If I were to graph y equals sine t. One cycle starts at the origin. It ends at 2 pi. The middle is pi. Where's the high point? 1. And the x value? Pi over 2. 1. And the low value? 3 pi over 2 comma negative. All right, so there's the sine wave. And of course it keeps going on and on forever in both directions. What's going to happen with cosecant? For example, right here when t equals 0. When t equals 0, what can you tell me about cosecant? Well, cosecant of 0 is? What's sine of 0? Sine of 0 is 0. Cosecant is 1 over sine, so what's 1 over 0? 1 over 0 is undefined. Same thing's going to happen at pi, isn't it? If I try to plug pi in, cosecant of pi is 1 over the sine of pi, and 1 over the sine of pi is 1 over sine of pi is 0. 1 over 0 is undefined. Same thing's going to happen at 2 pi. Sine of 2 pi is 0, so I'm going to get 1 over 0. That's undefined. What happens on graphs when you have a number on top like 1 and you get 0 on bottom and you get undefined? What's that tell you about what's happening with the graph? You get vertical asymptotes. So everywhere that sine is 0, our cosecant graph is going to have a vertical asymptote. Asymptote. It's got one of these vertical lines that it gets close to and never touches. So there's going to be an infinite number of those. Lots and lots and lots. All right, what's going to happen in between these two vertical lines? Well, what happens at pi over 2? Sine of pi over 2 is? It says so right here. Sine of pi over 2 is 1. So cosecant of pi over 2 is going to be 1 over 1. 1 over 1 is still 1. So I'm going to have that dot right there still for my cosecant graph. What happens at pi over 6? Pi over 6 is right about here. What's the sine of pi over 6? Sine of pi over 6 is 1/2. That's correct. Sine of pi over 6 is 1/2. So cosecant is going to be 1 divided by 1/2. What's 1 divided by 1/2? 2. So cosecant is going to have a dot up here. Like so. The sine of pi over 6 is 1/2. So cosecant is going to be 1 divided by 1/2. 1 divided by 1/2 is 2. So when I have t equals pi over 6, my height is going to be 2. Because that's where I drew it. That's at pi over 6. So this is pi over 6 right here. How did I get to that 2? Cosecant of pi over 6 is 1 over sine of pi over 6. And sine of pi over 6, that's one of those facts that we've memorized. That's 1 over 1/2. How do I take 1 and divide it by a half? I flip and multiply. So that's 1 times 2 over 1, which is 2. Okay. How about if I pick my angle pi over 4? That's right about there. Cosecant of pi over 4 is 1 over sine of pi over 4. The sine of pi over 4? Square root of 2 over 2. So that's going to be 1 over square root of 2 over 2, which is 2 over the square root of 2. I'm going to grab my calculator and type that in, just to have an approximation. That's about 1.41. And this dot right here, this dot was at a height of 2, so 1.41, that's going to be lower, isn't it? That's going to be right about here somewhere. Say that again. You get the trend. So what's the trend? It's like all the little humps are flipping up. All right, I've never heard it described that way, but I agree with you. So what's happening here is, as we go this direction, we got to get closer and closer to that vertical line. So in this direction, it's going to go like so. What's going to happen when I pick angles over here? Well, these are going to be angles in quadrant 2. Sine is still positive in quadrant 2. And it's going to have to get close to that vertical line. They're going to be positive still. So cosecant is going to look like that there. What's it going to look like between the next two lines? The humps are going to flip down because sine is negative, so cosecant is going to be negative. Here it's positive because it's positive. Here's negative. So what you get are a bunch of humps, is a nice description, I suppose. They look kind of like parabolas. People always want to tell me they're little parabolas in the middle, but they're really not parabolas. How do I know they're really not parabolas? Parabolas don't have asymptotes, do they? So they look kind of like parabolas, but they're really not. Parabolas don't have asymptotes. So I don't pronounce it correctly. I can live with that. All right. All right, so there's a list of where those vertical lines where the graph never touches occur. Yeah, I can pronounce all those words correctly. for the cosecant. How is secant going to be different? It's going to be 1 over cosine. So how's that going to change our life? They won't be further apart. Rather, they're going to be, no, they'll be vertical still. How are sine and cosine related? Sine and cosine are the same. They just differ by a phase shift, a horizontal shift left and right. So how are these vertical lines going to differ if I deal with a cosine graph? They're just going to have a phase shift. They're going to be moved over. Yep. So again, what I would do is I would begin by drawing a cosine graph. Cosine looks like so. One cycle. Where does cosine hit 0? It hits it right there and right there. What are those t values right there and right there? So this would be 2 pi right here. So this would be pi. So this 0 right here happens at pi over 2. And this 0 hits at 3 pi over 2. So where are the vertical lines going to be? For sine, when I dealt with cosecant, the vertical lines were at 0, pi, 2 pi, 3 pi. They're going to be at these zeros. The vertical lines will happen at pi over 2, 3 pi over 2. Where's the next one? Well, this is 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. The negative ones? Negative pi over 2, negative 3 pi over 2, so on and so forth. All right, so there's what the graph of secant looks like. It looks almost exactly like the graph of cosecant. It's just shifted because the cosine wave is shifted. Questions on that? So here, for y equals secant t, these vertical lines, they happen at negative 5 pi over 2, negative 3 pi over 2, negative pi over 2, pi over 2, pi over 2, 5 pi over 2, No. So in just a second we'll draw another graph and I'll show you exactly what I would expect to see. Okay, so if I asked you to graph y equals 2 cosecant t, here's what I would expect to see. Oh, I should have mentioned this. On these graphs, on both secant and cosecant, what's the period? 2 pi, because I get 1/2 of a cycle and then 1/2 of a cycle, and that distance still happens in 2 pi. So the period is still 2 pi for these graphs. Nothing changes there. Okay, so if I asked you to graph y equals 2 cosecant t, what I would do first is I would graph y equals 2 sine t, the way we've always graphed it. And it does help if you have extra colors, but if you don't have extra colors, you can do with that too. What's the graph of y equal 2 sine t look like? No? What does this 2 change? No. The 2 outside like this changes the amplitude. So its period is still going to be 2 pi. So this sine wave is going to look like so. And what I told you the other day, when you draw a sine wave, I want to see one complete cycle. There's one complete cycle. And I want to see the 5 key points labeled. So what are our 5 key points here? The origin. Where does it end? 2 pi, comma 0. Middle? Pi, comma 0. And then this high point? Pi over 2, comma 2, because our amplitude changed. And the low point? 3 pi over 2, comma negative 2. So first you would draw your sine wave. And then you're going to draw in your vertical lines. Like so. And then you draw your cosecant wave. So that's what I would expect to see. So really, drawing cosecant graphs, there's really almost nothing new. You draw the sine wave just like you did in the last section, and then all you got to do is draw the vertical lines and then flip the pictures, and you're all set.
Do we need to write anything?
No, because you've got what you have the key points marked, the high point and the low point, and you've also marked the vertical lines for me by marking these points. So you're all set, you're all good.
So if you asked like that, the green question on the quiz, and then we wrote that same set graph, would be right?
Yes, that's exactly what I hope you write on the quiz. Exactly what I've written on my piece of paper. Other questions about that? Okay. So what if I asked you to graph y equals secant of t, we're always using t's in this section, not x's, t, you want plus or minus?
Plus.
Positive.
Plus, give me a number. Usually the number would have pi's in it.
2 pi. 1/4 pi.
No, pi 4.
Pi 4 over 2.
That's
Pi over 5. We've never used pi over 5 before. I like that idea. Pi over 5. Okay. So again, on your quiz, on your test, what I would expect you to do is first draw the cosine wave. So I would first draw y equals cosine of t plus pi over 5. Okay, so what does that t plus pi over 5 change? It shifts the graph left. So this is a phase shift is what we call this. So this graph is going to start where? Negative pi over 5, comma 1 because it's a cosine graph. All right, so this starts at negative pi over 5, comma 1. And then it's going to end over here somewhere. How do I figure out where it ends? I add 2 pi because that's the period. The period has not changed, has it? All right, so I'm going to go down to the bottom here. I take 2 pi and I subtract pi over 5. That's 10 pi over 5 minus pi over 5. That's 9 pi over 5. So that's where it's going to end. So it ends right here at 9 pi over 5, comma 1. Then it has a low point right halfway in between. Right there. So what's the low point? Well, the y value is
4 pi over 5.
negative 1, and you're telling me the x number is 4 pi over 5, and I'm trusting you, and I'm writing it in pen. Is he correct? Yes, and how did you get it? Right, it's going to have a pi over 5 in it, so it's halfway between negative 1 and 9. Halfway between negative 1 and 9 is 4. So it's 4 pi over 5. All right, it's going to hit the axis halfway in between. So we got to be halfway in between negative 1 and 4. It's halfway between negative 1 and 4. One and a half. All right, so that one's kind of weird. So halfway between negative 1 and 4 is 1 and a half, which I'm going to call 3 halves. So we're going to have 3 halves of pi over 5. What's 3 halves of pi over 5? No, calculator. That's 5 over 1. So that's 3/2 pi times 1 over 5.
3 over 10 pi.
3 pi over 10. Alright, so sometimes when people pick ugly numbers like pi over 5, our numbers get a little bit harder to calculate. That's 3 pi over 10. Alright, and then we got the last one right here. So now we need to be halfway between 9 and 4. Thirteen halves. So it's going to be 13 pi over 10, comma 0. Same trick as I had here, except I'd have 13 over 2. I would flip and multiply, I'd get 13 pi over 2. Okay, so there's our one cosine wave. So that one was a little bit harder to draw because somebody had to be mean and pick pi over 5. Guess that was me. We draw our vertical lines. How do I know to draw those vertical lines right there? Because that's where I hit the zeros. Where I hit the zeros, that's where the vertical lines are going to happen. And then I draw my secant piece in between the dotted vertical lines. So there would be my answer. So again, drawing a secant graph is really just drawing a cosine graph.
Start finish double. Should you make them double to do?
I wouldn't care if you left this part off and this part off. That would be fine because you've drawn one complete cycle. It just bothered me for some reason to leave half of it off there, so I drew it in. But if you gave me that picture right there, that would be perfectly correct and you would get a perfect score on that problem. Other questions? Okay, so the last graphs we have are tangent and cotangent. I don't know. Tangent, I remember, is sine over cosine. So the first thing I know about tangent is I'm going to have some of these vertical dotted lines again. Why do I know I'm going to have some of these vertical dotted lines again? Because cosine can sometimes be 0. So whenever cosine is 0, tangent's going to be undefined, which means we have a dotted vertical line. Where is cosine equal to 0 again? Pi over 2 and 3 pi over 2.
5 pi over 2.
5 pi over 2 and
7 pi over 2.
7 pi over 2 and all the negatives, right? So, for tangent, tangent's going to have the exact same vertical lines as secant did. Exactly the same. All right, I'm going to draw those in first. Here's pi over 2. Here's 3 pi over 2. Here's negative pi over 2. Here's negative 3 pi over 2. Now, remember that chart that you've memorized for all those angles in quadrant 1. What happens for sine when I start at 0 and I go to pi over 2? Sine starts at 0 and it keeps doing what? It keeps getting bigger, doesn't it? So, on this fraction, when I'm picking angles in quadrant 1, my top's going to keep getting bigger. What happens for cosine in quadrant 1? It gets smaller. So what happens if I take a number that's getting bigger and I keep dividing it by numbers that are getting smaller? What happens to the fraction altogether? All right, so let's pick some numbers. So I'm going to start with 0 divided by, I'll use integers to make life easier, 10. What's 0 divided by 10? 0. Then the top gets bigger, but the bottom gets smaller. What's 1 divided by 9? 1/9. That doesn't change much, does it? The top gets bigger. That's 2. The bottom gets smaller. That's 8. That's a fourth. Let's skip a couple here. The top gets bigger. The bottom gets smaller. So as the top gets bigger, and at the same time the bottom gets smaller, what's happening to my numbers?
They're approaching 0.
Aren't they going away from 0? It started at 0.
Yeah, but as you keep going, you want to keep going to 1.
Oh no, I can keep going. I can make the top bigger, and I can make the bottom smaller. Well, that's 1.5, isn't it? It keeps getting bigger, doesn't it? So I think what has to happen is tangent of 0 is 0. Tangent of 0 starts right there. As my numbers get bigger here, up to this pi over 2 line, my top's getting bigger, my bottom's getting smaller, so my numbers in all are getting bigger. So I get something that looks like that. What if I pick numbers that are a little bit smaller than 0? So those would be angles like minus pi over 6, minus pi over 4, minus pi over 3. Those are all angles in which quadrant? Not 3. Where's minus pi over 4? It's in quadrant 4. In quadrant 4, is tangent positive or negative?
Negative.
Tangent is negative. So my values over here are going to be negative. And you can do the same trick. The numbers on top are going to get bigger. The numbers on the numbers on top are going to get bigger. The numbers on bottom are going to get smaller, but they're going to be negative. So it's going to do this in that direction. Okay? This is pi right here. Tangent of pi happens to be 0. If I pick angles that are between pi and 3 pi over 2, what quadrant am I in? Pi and 3 pi over 2, that's quadrant number 3. In quadrant 3, tangent is positive. So I'm going to get that deal again right there. If I'm between pi over 2 and pi, I'm in quadrant 2. Tangent's going to be negative. So that's what tangent looks like. Tangent keeps repeating over and over again. That same exact picture between its asymptotes. So tangent has one complete cycle between minus pi over 2 and positive pi over 2. How long is that? What's the period? Period is only pi. So tangent is very different from the other 4 graphs we've looked at in the sense that its period is smaller. Period equals pi. So when you draw a tangent graph, what am I going to expect to see? Pretty much that. What I'm going to want to see is I'm going to want to see one complete cycle. So one complete cycle means you need to give me 2 asymptotes and 1 point in the middle. So for a tangent graph, I only need to see 3 things. For sine and cosine, I needed 5. For tangent, I only need 3. 2 asymptotes and a point. How's cotangent going to be different? It does 2 things, actually. You're close.
Well, wouldn't it shift?
It's going to shift also. Why is it going to shift? Because it's cotangent? The reason it shifts is because it has sine on bottom. So the asymptotes are going to happen when sine is 0. When is sine 0? 0 and 0 and 2 pi, and there's one in between 0 and 2 pi. Pi. So sine is 0 at 0, pi, 2 pi, 3 pi, 4 pi, negative 2 pi. So the first thing that's going to happen, the asymptotes are going to shift. So the asymptotes are at 0, pi, 2 pi, negative pi, so on and so forth. And then, I'm not going to go through all the work, you can just believe me on this. What happens is, it actually goes the opposite direction. So, it's going to look like so, repeating over and over and over again. And where does this point happen right here? Where's this 0? Halfway between 0 and pi, which is pi over 2. So tangent and cotangent are very similar. Again, there's a phase shift between them and a flip in this case. Questions?